Welcome to the DIY Honda Garage channel. The DTC P062B is a diagnostic trouble code indicating a malfunction within the Powertrain Control Module, PCM, internal circuit. This error typically arises when the PCM detects an anomaly in its internal communication, leading to improper functioning of its components. The PCM is essentially the brain of the vehicle's engine management system, controlling critical functions such as fuel injection and engine timing. In the Honda Accord from 2012 to 2017, the PCM's integrity is vital for robust engine performance. If the PCM identifies a fault, it will trigger the Malfunction Indicator Lamp, MIL, to alert the driver. Understanding the role of the PCM and the significance of this code is essential for accurate diagnosis and repair. In conclusion, understanding DTC P062B and the critical role of the Powertrain Control Module is paramount for effective troubleshooting and repair of the Honda Accord from 2012 to 2017. Accurate diagnosis involves thorough investigation of battery conditions, PCM wiring integrity, and the implementation of corrective measures followed by verification of repairs. By following systematic steps and acknowledging symptoms early, technicians can mitigate the risk of further complications. Ultimately, consistent maintenance practices, not just reactive repairs, are necessary to ensure continued performance and reliability of automotive systems. Emphasizing these principles will yield a smoother experience for both the vehicle and its owner. The DTC P062B signifies a failure in the internal circuit of the Powertrain Control Module, also known as the PCM. This module is responsible for sending commands that control the fuel injectors, which in turn supply fuel to the engine. The fuel pressure is modulated by the high-pressure fuel pump, which receives instructions from the PCM. If the PCM detects internal miscommunication or matches discrepancies in current readouts it manages, particularly between the ejector driver and the CPU, this fault will register as DTC P062B. The PCM, typically located near the engine bay to enhance connectivity and minimize signal delays, monitors various components and communicates vital operational commands that help regulate performance and efficiency. There are several possible causes when diagnosing DTC P062B. The most noted cause is the internal failure of the PCM, though other issues may lead to this malfunction as well. The communication between components, specifically between the injector driver and the CPU, is crucial for accurate performance. Failed communication can lead to incorrect readings and system errors. Discrepancies in current readouts can also trigger this error, whereby the actual current flowing through the injectors does not match the commanded values set by the PCM. It's important to perform a complete assessment, as there may be additional underlying problems contributing to this DTC, not explicitly mentioned in this diagnostic guide. When a vehicle registers the DTC P062B, it will usually present some noticeable symptoms. The most immediate symptom is the illuminating of the Malfunction Indicator Lamp, MIL, which alerts the driver to a fault in the engine management system. Additionally, the vehicle may experience engine performance issues such as misfires, reduced acceleration, or rough idling due to improper fuel injection timing. As a result, it may also lead to increased fuel consumption as the system attempts to compensate for detected inefficiencies in fuel delivery. Recognizing these symptoms early on can facilitate quick diagnostics and repairs, minimizing further damage to the engine or associated systems. The first troubleshooting step for DTC P062B requires you to verify the vehicle's battery voltage. A crucial aspect of the Powertrain Control Module's function relies on sufficient voltage levels. The system expects a minimum battery voltage of 7 volts while the engine is running. This ensures the PCM can operate properly and communicate effectively with other components. If the battery is below this threshold or is in poor condition, it can lead to erroneous fault codes and malfunctions. Conducting a comprehensive battery test can reveal whether the battery's voltage and overall health meet operational standards, providing a clear path for further diagnostics. The second troubleshooting step involves examining the wiring and connections associated with the Powertrain Control Module. Due to environmental factors, wiring can become corroded or damaged, leading to poor communication between the PCM and other critical engine components. Thoroughly inspect the connectors for signs of wear, corrosion, or looseness. Additionally, ensure that no wires are frayed or broken, as these issues can hinder the PCM's ability to operate effectively. Properly secured and intact connections are paramount for reliable performance, and addressing any faults found can often rectify the DTC. For the third troubleshooting step, the objective is to clear any diagnostic trouble codes stored in the PCM using a scan tool. After performing necessary repairs or adjustments, using the scan tool to clear DTCs is essential to reset the system's memory. Following this, a system test drive should be conducted to ensure that the PCM is functioning as intended and that the MIL does not illuminate again. Observing the PCM's response during this test drive can help confirm whether the original issue has been resolved. By fully completing this step, any remaining faults can be identified or alleviated, solidifying the repair work completed. The final repair verification step involves confirming that the DTC P062B has been successfully cleared and that the engine operates normally following the applied repairs. This involves rechecking the DTCs with your scan tool to ensure that no error codes remain active or pending. Observations during engine runtime behavior are crucial. The engine should run smoothly without performance hiccups, and the MIL should stay off during operations. By taking these steps, you can be confident in the integrity of the repairs made and the functionality of the Powertrain Control Module. Ensuring a thorough verification establishes reliability, giving peace of mind to both the technician and vehicle owner. Preventive maintenance is vital to avoid future occurrences of DTC P062B. Regular diagnostics on the Powertrain Control Module can help identify prospective issues before they escalate into faults warranted by DTCs. Moreover, conducting periodic battery maintenance checks ensures that the vehicle maintains a healthy voltage, mitigating the risks of electrical failures in the PCM. Additionally, inspecting the wiring and connectors can prevent corrosion and damage caused by environmental factors. By adopting these preemptive measures, you can enhance the longevity of the vehicle's engine management system and promote reliable operation. Please like and subscribe to the channel. See you next time.